Before I move to the next, we're going to give the control to Ed Pound, Executive Director of the Project Production Institute. I really want to thank Hess Corporation, Tripatra, McKinsey & Company, A.G. Kunz, Tengiz Chevron, and Microsoft for their participations. What an amazing set of stories. Every single one of them different, with different applications, different challenges, some of them in design and engineering, construction, and that give you, I hope, for those of you that are on the other side of the screen, a good sense of what is possible and what people are doing now. Because I don't think we are talking about investing in research or things that are not even doable. I think these are industry professionals that are showing us how things are being done as we speak. Okay. So really, really much appreciated. And with that being said, I leave you with Ed Pound already on video, and he will actually summarize a few things for us. Over to you, Ed, and thank you so much.
All right, thanks, Roberto. Yes, absolutely wonderful presentations by everybody. As a matter of fact, there's so much information, so much processing going on in my brain. I overheated, had to take my jacket off. So relaxed, enjoying all the feedback. Hope everybody else is also. What I'm going to do really quickly here, what I'm going to get to, talk about the ending first, is I want to get what your takeaways are. So people have been listening to this. This particular track is for folks who are not so familiar with PPM. So when we get to the end of this, I'm going to do some review. And then when we get to the end, we want to get your input on takeaways. So without further ado, let's go through that. So the first thing to do is go through what people talked about, and you'll see why I'm going to do that when I'm through with that. But if I look at what Pathman talked about, and I'm picking out one slide from each presentation. So Pathman was looking at and identified how it was really important to look at variability, and looking at variability and capturing the reasons for variability really helped them move from where they were to where they wanted to go. Now, there's a lot of other things involved. I'm just picking out one particular concept from each slide. Dira talked about production system optimization and looking at inventory and this idea, and I think actually Gary mentioned that early on, this idea of like, yes, you can ship everything out to the site and you can have it all lying around so you're looking at it instead of looking for it. But what you've also done is you've tied up a lot of cash, and there's a way to be able to optimize how much inventory that you do need. And I think Craig mentioned that actually. The point is not zero inventory. That's a fantasy. You need some amount of work in process, some inventory in your process, and understanding what the right amount is. It's what's key. And that's what you get from a project production management understanding. Jan talked about production system optimization. And this is really interesting because these were really big facilities, specialized facilities. This is not your standard, pipe spools that you're making. And doing the production system optimization and the modeling ahead of time enabled them to really help the client understand that they could save 5 months in the schedule, and also work, which was counterintuitive. It would be faster if they worked with less work in process. And so that was a big takeaway and really helped them and got a lot of good insight. It's a new way to think. We'll talk about that in a second, but really helpful for them. Alex was an amazing description of how data centers are going up, and then Adrian kind of finished with a discussion on the same talk. But yeah, his thing was, look, we're not building things in place. It's not sort of the craft approach. What we're trying to get with data centers, if you remember, he said design in one day, okay? And so that's really now looking at all those levers that we talked about earlier and applying those in the PPM framework to get to that, because as you saw from Adrian's map, that's a massive scale of facilities that they're maintaining throughout the world, and that's what makes our internet go. So very interesting application of project production management. They are also really pulling all of those levers together to get to that design in one day. Dorina and Ludwig talked about CAPE applications. This is a favorite of mine because I actually was standing right there by those guys who were lifting those pieces in place. And they were talking about doing the work in practice, basically modeling it and doing it ahead of time, right? And so you understand that, oh, wait a minute, I'm doing 93 of these expansion loops. That sounds like a production process to me. I mean, it's not a permanent production process. I'm not making automobiles, 100,000 a year for the next 20 years or whatever, but 93 over a couple of years or whatever the time frame is, that's a production process. And maybe I should look at that ahead of time, look at the design and look at doing a first run study, the installation ahead of time to learn about that and learn about my production system before I do a full scale rollout. And so a lot of good results from that, cycle time reductions, big savings on labor. And then Jim talked about working a project and how to get one that's out of control in control. As he mentioned, this is one of those projects that it's not like they haven't done this before, but this one in particular got out of control. And so needing to come in and work with people, and it was kind of a sequential process. First thing to do is understand what the problems are. What is my production system? What are the causes of variability? Because if you look at this commit reliability from an operations science standpoint, that's the same as demand variability. And demand variability causes an increased requirement for resources is the simplest way to put it without going too far down the rabbit hole. The point being that more variability requires more resources to manage. And by putting a project production structure on top of this and looking at it, you don't necessarily, you get control of that and you reduce your own self-induced variability. I mean, there's good variability. I mean, the fact that you're building different structures for different owners, well, that's variability. You don't build the same thing for everybody all the time. That can be good variability, but you have bad self-induced variability where people don't understand what's going on. They don't know where the material is, that sort of thing. And that variability, whether it's good or bad, sucks up resources. And being able to work on commit reliability essentially is reducing your variability in your production system and enabling you to perform better with fewer resources. And Craig talked about those huge modules that they moved from Korea or Italy or wherever the fabrication location was to the installation site. And being able to understand, well, wait a minute, I don't need to spend an extra, $50 million for an extra crane. If I just understand where my constraint is and work on the constraint, which is a basic operation science principle, I can get the same or improved throughput, maybe even with minimal investment of resources. You won't find every time that I shouldn't invest in resources, but a lot of times what people will do is without an operation science view, they'll say, oh, I got to cut costs, cut costs, cut costs. Well, sometimes the idea is to invest a little bit more in a resource, for an extra crew to save you a much bigger cost later on down the road, like for instance, a crane. And then of course, as we mentioned, the Microsoft Cloud operating at scale, that's a huge scale, that's worldwide scale. And they were there, you can see, just trying to coordinate this magnitude of installation, being able to reduce cycle times by 50% and increase on-time delivery to 95%. Now, wait, increase on-time delivery by 95%. What's that similar to what we just talked about? That's the same as commit reliability. So if your suppliers are more reliable, it's the same as your crews on site being more reliable. And what you're doing is you're reducing variability, which requires less resources to accomplish the same thing. Okay, so great insights. Really loved those. It's a different way to think, particularly if you're not if you're not familiar with PPM. And so we come back to, oh, wait a minute. I don't think anybody really talked about the iron triangle. there was some discussion about productivity, but what you found was you increase productivity not by trying to keep everybody busy all the time, but by understanding your project production systems and using those as effectively as possible. And I think, as Jim mentioned, it's kind of a stepwise process. You know, as you push further and further into where the problems are, the causes of variability, you get productivity increases, right? And so it's just a different way of looking at things. You know, obviously you're going to have scope and quality. That's what you're going to have, a schedule, and you're going to have resources, right? But what and when by who is not going to get you the results that you want. And that's a really important takeaway. We're not saying you won't have those. You're still going to have a schedule. As Craig mentioned, you know, what they said now is they're going to understand their production systems, and then they're going to create a schedule, which is really the way to go about it. It's not saying that you're not going to have a schedule, but just looking at a schedule is not going to give you, it's a prescriptive model, basically. It says what should happen. It's not going to tell you what will happen. And so here we come to the sort of a central concept. If I look at the schedule, that's giving me dates and progress. That, you know, essentially is telling me what my demand is. But what really determines, that's what should happen. What really determines what will happen and what can happen are your production systems. And it's a great way to think about this. Todd Zabel said just the other day, it's basically like you're on, you know, we've crossed the river. If you're looking at a project production management approach to capital project delivery, basically you're on a different viewpoint. You're on the other side of the river, and you still, if you're looking at it just from the classic project controls schedule control approach, you know, you're just in a different world. And so what we want to do, and hopefully we did for you today, was at least to kind of give you an idea that, hey, maybe there is a different way to look at things, because it's guaranteed that your project, your production systems in your project will tell you what can and will happen. And that's what's key really to managing and delivering projects successfully. Also discussed was, I think Gary talked about this early, but the tendency for project managers, and, you know, he said this when he was evaluating how he had designed the Chevron project system, is to just load up different steps with inventory. And the drive for that is people are optimizing locally, and they think, oh, if I have enough inventory, I can just really keep busy and keep everybody busy. And if everybody's busy, things will get done more quickly, and then I'll be more productive and make more money. But that's not the way the world works. That's more kind of an accounting model. You know, get 100% utilization, and I do more, and so the resources I'm using are more productive. But what really happens in terms of the project production system behavior is that work in process or inventory is essentially time. Okay, and so the more inventory you have, the longer it's going to take to get things done on average. More time means more cost. More time and more cost means lower ROI. So that's an insight that you get from looking at projects as a collection of production systems. And then, of course, we didn't really go into this too much, but the point is there is science at the heart of this, right? Observing nature. These are descriptive models of the way your projects will behave. And, you know, there's a relationship between work in process and cycle time, work in process and throughput, and then your batch size. Now, batch size, how does that fit with projects? Well, when I'm talking about work phase planning and, you know, what the size of my work package is going to be, that's a batch size. And what you see is the larger the batch size is, just, you know, intuitively looking at this, the longer my cycle times. If I'm doing agile and I'm trying to determine, you know, my product backlog and what's going to be the work duration for my sprint, oh, well, you know, that's actually a batch size decision. The point being that those are all structures that people work in. If you don't understand the science, the underlying science behind that, you might end up tripping over yourselves with all the best intentions. And so project production management is based on the operations science, these fundamental concepts that describe behaviors of these systems between inventory and capacity and and response time and variability. And understanding that is the key to understanding how your project production systems work. So as mentioned, what's really going on is, it's not just about what and when and who, it's about your product and your process design and how those work together. Alex, when he was talking about data center design in a day, really was taking that to the extreme where, that forces you, saying that's your goal, really forces you to look at all 5 of these levers together, right? But sometimes what happens is you walk into a project, and some of you might be on them now, where look, the product's already designed, the process is in place, and I'm still behind. I can't change those 2 levers. What am I going to do? Well, you still have a couple of levers that you can work with. There's capacity and inventory and variability. If it's a situation where we've seen it before, where, oh, well, guess what? We're doing 2,000 pipe spools and they're already on site. Okay, well, that takes that lever out. And so now I have 2 left. The point is, this is a really simple, straightforward, an authentic model in that it reflects actual options to what you can do to get your projects under control. The 5 levers: product design, process design, capacity, inventory, and variability. And so understanding your projects as a production system will lead you to repeatable and predictable control of your projects. And of course, that's what drives the PPM framework. And Gary talked about this earlier, so I won't rehash it. But you have operations science, and then you have actually 3 separate segments of project production management, which we've all touched on today. Production system optimization, that was what Jan talked about. Computer-aided production engineering, Darina and Ludwig talked about that. And project production control, I know Jim talked about that. This is all mixed throughout. It's not like you're just going to do one. You might walk in and you might do only one. You might do some combination of them. But if you're looking at projects and production systems, these are the approaches that you would take to understand how to control that system to get the results you're looking for. So in review, rates drive dates, right? The rates of your project production system. Dynamic projects require rapid replanning, and people doing the work, and Gary emphasized this morning, do the real planning. As he said, he walks out there on the site and they say, how's your schedule look? And they say, oh, you mean that thing on the wall that we never pay attention to? The people doing the work need to be doing the real planning, and it's all based on science. Okay, so that was a really quick run through. What we'd like to do now is get your feedback, get your takeaways. And so what I've done here is I put basically the poll. Okay, so hopefully you've been with us before, but if not, this is a QR code that you can scan with your phone. You should also have in your chat window this link, which you can click on. And what I'd like for you to do, and I'm just going to leave it here for a few minutes because it takes a few minutes for people to go through this. Describe your takeaways from today's sessions. That means all the sessions on how leading companies implement and benefit from PPM. So not looking for a long, a lot of prose, just 1 or 2 words or 3 words per takeaway. And then what we'll do is we'll accumulate those results and see what we come up with. All right, so I'm going to leave it there for a second or for a minute or 2, and then we'll see what the results show. While I'm doing that, Roberto, did I miss anything there?
I think, you highlighted all the main elements. I think it's important to really understand how production systems behave. And there's a method to the madness, right? There's a framework. This is not about what you think. This is not about what I think. This is about how a production system behaves, and it's beyond someone's opinion. It gets down to a specific behavior, right? And we're not going to understand that behavior by looking at schedules. Schedules these days are being used for other purposes. And I think what we are seeing, and all the stories that the experienced speakers brought to us today are a a proven case for, that the idea behind production systems is not just an idea.
Right.
It works. People are actually doing it. People are actually getting amazing success, like what Microsoft shared with us, reducing cycle time by 50% on the supply of equipment, as well as being able to move from 70% to 90 to 95% on achieving the delivery targets they had. So, I mean, I'm personally blown away by the stories that we heard today, to tell you the truth. But we'll see what people
Let's
say
have a look.
through the poll. So back to you.
All right. Yeah, and actually, see, I might have to. Oh no, here it comes. Whoa, there it comes. Oh, look at that, right at the center, whip. That's great. A big shift in thinking. Absolutely. 5 levers. Oh man, you guys are getting it all. Behaviors. Absolutely. Little's law. That's great. Here we go again. Production systems. Awesome. Yeah, and while this is bubbling up, I can't resist, working with PPI. If you're interested, there's a lot of information on the website. We would love to have your involvement. We supporting both academic efforts and industry efforts and training efforts. So keep that in mind as you're considering what you're gonna do tomorrow. Variability. Wow, yeah, you guys are hitting all the high notes. Senior management support, contractors and vendors. WIP, variability, production systems, 5 levers. That's pretty much it. Wow, that's really cool. What do we got there? No manual, provoking culture. I like that. Time well set, spent, optimization system, mathematics space. Indeed, that's a part of the operations science. SPS, robotics, dynamic modeling. Awesome. All right, we're just about there. We got another reload. Oh, that's 22 folks. Thank you so much for your input there. It looks like you're catching you're picking up on the concepts. Definitely. That's great to see.